we'll start the next session now. This will be conducted by Mr. Sudhakar. Sudhakar is the communication and network specialist at ARTPARC and also specialist scientist at the ECE department in Indian Institute of Science. Sudhakar comes with rich industry experience from Motorola, Nokia, Siemens, and IBM. He has been involved in 5G system development at IASC and is also technical editor for the IEEE Communications magazine. He has been offering courses in IASC in 5G cellular communication under the continued education program. Sudhakar happens to be the right person to give us an overview of 3GPP and cellular communication. So this will be a technical session. Let's make best use of it, listening from the expert Sudhakar. Thank you. Over to you, Sudhakar.
Thank you, Sheila. Good morning, and thank you all for giving us the time and opportunity to share our ideas and views and share a bit about what we are doing as part of IAC as well as part of the ARTPARC. Today for this session, we have total about 145 registrations, out of which I see majority of you are already having exposure or expertise into the 5G systems or the mobile communication systems, etc. That's really good aspect, I feel. And the average experience of the participants stand at about 7.8 years. So I see some of you are freshers and some of you are into the academics, some of you are in the industry, etc. So I would like to keep the technology to a minimum, I would say, because in the interest of time also, I have time till 12:30, that's 70 minutes. So I'd like to touch base upon the 5G aspects, 3GPP specifications, then a little bit about 6G, what is 3GPP is looking at, and what we are doing at both these places in the 5G testbed at IASC as well as at ARTPARC. So this is the agenda I'm looking at. And in between, I take pauses for questions and let us be interactive. That's a mode I'm looking at. Sheila has already given a brief about me. So I worked in Lucent Bell Labs, Motorola, Nokia, Hewlett Packard, and IBM. While I was at IBM, again, I was working with Nokia Excel. Perhaps IBM is the only stint of services model I was working into. Otherwise, I was more an integral part of the product development at in wireless technologies. And I'm associated with EC department since 2019 as a specialist scientist and testbed manager at IAC for the 5G testbed. And I was involved in large program definitions, and I was one of the members in program with Mighty. And currently, I'm trying to build a test facility for mobile communication systems for cyber physical systems at ARTPARC. So when we think about the 5G, these capabilities are what the 3GPP has agreed. On all these slides, I have given source from which I have taken these pictures, either on the left bottom or right top. Usually these are the two places I keep the references. So when you think about the 5G system, it is like peak data rate support for the system should be 20 Gbps, and user experience, the data rate should be 100 Mbps data rate. Like this, there are different sets of KPIs that have been defined with reference to IMT 2020 and IMT Advanced. There are two variants here. IMT stands for International Mobile Telecommunications Union, these KPIs or these parameters or the capability set that 5G is envisioning has been classified into three variants of operations. One is enhanced mobile broadband, which we generally use, and other part is ultra reliable low latency and massive machine type communication. So what we currently witnessing in the 5G deployments are nothing but the enhanced mobile broadband. Still, industry has not seen, or none of us have seen the functional URLLC platform or a massive machine type communication system yet. Uh, that is, in one way, in my personal opinion, okay, research towards 6G is a required thing, but at the same time, we need to really look at how we bring this full capacity and capability of 5G to action. So these are the two different flavors. According to 3GPP, every 10 years we will have one new release, new version, etc. But at the same time, we need to see really we have to materialize the complete functionality of an existing release. So for this, the current challenges that we have at hand are having a demand. There is not enough demand with reference to the um, data rates or the user experience, etc. If someone asks us, what is that the 4G cannot do and why I need 5G? There is no clear cut answer yet. That is mainly because there are no ultra reliable latency based applications in the system. And similarly, massive machine type communication, which talks about a device density of 1 million device per square kilometers. Still, we don't have that level of automation that has went into the systems. That is the reason why we don't see, though there are definitions, we don't see the systems being built around this functionality. So these are some of the challenges that we need to understand and build the systems for. So now there are two things. One is the research team looking towards sixth generation, and industries working towards enhancing and utilizing the capabilities of the existing system. Both these flavors need to go hand in hand and arrive at a common understanding of what a generation needs to address. So for that, there are collaborating agencies, which I'll talk about shortly. Together, industry, academia come forward and define the standards and specifications. That is how the 3GP arrives at defining a release. And when you look at the release calendars, um, NR15 is supposed to be the base release of 5G system, the first NR release. Or NR is it stands for new radio, and release 15 is the base variant. So until then, or release 9 to 14 are known as LTE or LTE advanced. Once those releases are done, release 15 has started, and that is known as the first release of fifth generation system. And fifth generation has a set of intermittent releases that keep going until we reach a sixth generation system. We will see how and what do we mean by these intermediate releases, or what do we mean by a particular release itself. So, okay, NR15 has been baselined and people have started building the system. With that, we can create a platform and we can create um, a base platform which meets the capabilities to some extent. To be honest, none of the systems can be 100% compliant to any release because of the business dynamics, and specific companies have their own um, needs and focuses. Some people may be looking at providing voice call as the basic functionality that they would like to prioritize. Someone may be prioritizing a data related networking, etc. So depending on the company's profile, depending on the business case that company sees, they adopt these releases to certain extent and build their product portfolio. And when you see, okay, let us take the example of release 18 here. Package content approved by TSG during, say, end of quarter 4 2021. This is currently the history. Once the package content is approved, content approval happens based on some of the technical review documents, TR documents is what we call. Based on those things, the um, consortium will meet together, and TSG stands for Technical Steering Group. These technical steering groups meet every quarter and they decide what should be the baseline for a particular system. Once that is the content is approved, then teams start working towards freezing the stage two. Stage two freezing refers to um, what would be the okay requirements we have done. So what would be the implementation model? Those things they have to do. And similarly, stage three freeze is if there are any late coming requirements, etc. We can have all those things and complete the definition of a particular release, and followed by that will be a code freeze. This coding freeze specifically refers to the message structures that the individual protocol units or individual network elements exchange. So that if a network element A, if I suppose I have A, B, C, three network elements in the network, element A can be built by some company, element B can be built by some other company, element C can be done by another company. There should be an agreed interface so that these entities can be interoperable. So that is where the interoperability principle comes into play. And this ASN1 freeze, abstract syntax notation 1, this ASN1 freeze actually um, defines those message structures that have to be exchanged. What would be the capacity of each part of each message that is carried across over the specific interface? Maybe I have um, a different explanation down the line. Um, but that is the way this thing happens. And why ASN1 is the next question. When you think about achieving this interoperability, I should have a common base on which I have to build the systems. That common base is defined in terms of abstract syntax notation. It is like a um, properly intended, properly indented English type of language where it defines what are the parameters, what is the size of each parameter, etc. And there are compilers for that ASN1 file which can build a code base for these message structures. Like for example, if I use a C compiler for ASN1 and extract this ASN1 file from the 3GPP specifications for a particular interface and build that particular ASN1 file with, say, C compiler, I will get C-based structures into the system. Those structures I can use for building that particular interface. That is the way this abstract syntax notation operates. And similarly, C, C++, Python, like this, various language compilers are there for the ASN1 system. And advantage with this is when you take this ASN1 code, that is a common code base that 3GPP is publishing. And when I take that and compile for my C language, and if someone else compile it for C++, still these message structures won't get altered. That sequence of um, elements of the structures that exchange or that carry the messages between the entities, they won't change. That is the advantage of that. And of course, we will have a encoder decoder on either side, and they do the encoding and decoding so that they can extract the messages accordingly. That is the way this ASN1 works. When it comes to the releases, okay, NR15 is the base release. 16 and 17 are there, and also the release 18. Up to release 18, it is called, I think 15, 16, 17 are the base releases for 5G. 18 is known as 5G Advanced. And 19 and 20, 20 is release 16. Um, like this release evolution keeps on going. And why do we need this evolution? When we are freezing the requirements, we are freezing once, and we are saying release is getting evolved. Why? This is the base for this. In the initial um, definition, we can have something like a non-standalone operation needs to be supported. Non-standalone is coexistence and cooperating with previous generation network, like, which is the LTE system in this case, or the fourth generation system. So fourth generation and fifth generation system, when they try to coexist, there are certain dynamics that we need to address, like how the control plane needs to be managed, how the data plane needs to be managed, or when I have the user equipment capable of talking to both these releases, how that particular UE enjoys the connectivity with both these networks. All these kind of things are non-standalone set. A standalone system is either I go with only 4G or I go with only the 5G system. SA particularly refers to the 5G system alone. What I mean is 5G radio, 5G core network, and 5G handset. Handset or the user equipment. That combination is known as standalone combination. Like this, there are several sets of areas that have been addressed. Say, for example, core network using the service-based architecture, support of virtualization. Again, virtualization is a principle by which we can um, share a particular hardware platform across different software entities or softwareized entities. Like I can have a part of the Gnode B or sets of Gnode Bs running on the one underlying hardware. I'm talking at almost 10 kilometer above the earth, but that is the fundamental model of virtualization. Having one hardware, and on top of that we put various entities. They share the underlying network or underlying entity. So that is virtualization concept has been introduced. Similarly, network slicing has been introduced, and network capability exposure. What this particular network functions can be utilized by adjoining units. Like if I have some application function from a third-party company, how that company can actually utilize the service of underlying 5G network. These are some of the typical definitions that have been released, frozen at the time of release 15. So if I live with just that set of requirements, that is not sufficient and that's not all, and it cannot meet everything. So in the 3GPP release 16, a VTX has been introduced. VTX is vehicle to any, vehicle to any app, vehicle to infrastructure, vehicle to vehicle, everything. So those things, X represents here any. It's like a wildcard character. So VTX, vehicle to different systems, that has been added as part of the release 16. So like this, a few additional things: AT triple system, access traffic steering, switching, splitting, etc. Similarly, enablers for network automation. There are some additional set of functionality have been added, and some of the functionality would have been enhanced from release to release because of some performance requirements or because of some capacity or capability requirements, functional or performance. Some of the enhancements would have been done in the new release. Like this, release evolution happens. When you think about release 17, side link communication has been added. And similarly, network operation has been extended to 71 gigahertz. Typically, NR or the new radio of 5G system operates in um, sub 6, what we call, originally it started as a below 6 gigahertz up to 6 gigahertz operation. 3 to 6 gigahertz is the typical frequency band for which we use. But there are three frequency ranges that have been defined, at least two: FR1 and FR2. FR1, or the frequency range 1, refers to um, 3 to 7.125 gigahertz, and FR2 band refers to something like 24, yeah, 26 to 28 gigahertz. That is FR2 band. Um, and further, that has been extended to into the microwave region. So depending on the use cases that 3GPP sees value, and different researchers and community, industry community, come forward and say, okay, whatever the allocated band or the identified band is not sufficient, so we need to enhance something. Like this, there will be different dynamics. So from release to release, 3GPP went on adding functionality to the system, and accordingly, they take certain time to get um, requirements freeze, stage 3 freeze, code freeze, all these things. So we keep updating the ASN1 functionality set, and that ASN functionality set is only incremental. It is not that I replace the previous one and keep the new set. It is not the way it is done. For any specific interface, when we define, we keep on adding the functionality to that, and interface terminal, so that within one generation, that particular interface is backward compatible. That is the main goal of having this kind of incremental interface definitions. Similarly, additional functionality like NR slicing and quality of experience parameters, or IoT over NTN. All these kind of various things have been added. And yeah, release 18 to 19. This again a similar story. We are enhancing the capabilities, and we are talking about different types of extended capabilities like URLLC enhancements, or time sensitive systems being brought in, or the location based or positioning. 5G positioning has been enhanced. Positioning, by the way, is there in the system almost from the second generation, but people have started using it to some extent in 4G, and in 5G it is going to be prominent. Still, I'm saying going to be prominent because EMBB still doesn't witness that part. But if I have a URLLC platform or URLLC based applications and use cases in the industry, then we will have to have, positioning becomes more and more critical. Similarly, time resiliency and the time synchronization systems would be needed, etc. Maybe in the interest of time, I don't go through these details of the evolution, but let us quickly move to the 6G part. What is the 6G is talking all about? Again, same story. We will have TSG work groups meeting at certain period, and defining the functional freeze, and the stage 3 freeze for release 19 happened. And from here to here, up to first end of first quarter 2027, that is the timeline by when we would expect sixth generation specification freeze, meaning ASN1 code freeze happens a little later here. So this is the point. End of Q2 is sixth generation specification freeze. From then onwards, we start seeing deployments and other things coming into the around us. So who is responsible, and what is the organization that is actually holding and running all this show? One is the International Telecommunication Union. ITU has three arms under that. One is ITUR. ITUR stands for radio communication, and ITUT and ITUD. These are the things. And ITUR is actually working through this study group 5 and working party IMT systems. These are the teams that are trying to define the framework for vision currently. This is the primary activity that is happening. And there are different parties to that. And team representing India in this journey is TSDSI, Telecom Society, Telecom Standards Development Society of India. They represent India, and they take the efforts that are done by the researchers and industry community within India to the 3GPP, and try to get the standards getting into the system. So that is the way we contribute towards ITU. And so what is this 6G is all about? So earlier we had these three things. One is enhanced mobile broadband. Another is ultra reliable low latency system and massive machine type communication. This is definition of IMT 2020, 10 years. That's the 5G definition. To that, sorry, there have been some enhancements done on all these three coordinates. And in addition to that, they have added three more, bringing artificial intelligence and communication systems, and ubiquitous connectivity, and integrated sensing and communication. These are the three additional quadrants that are being added. Immersive communication is like having a these reality systems in XR, VR, virtual reality or extended reality systems, where holographic communication, all these things will be taking place into the system. And in case if we can, or if we want to build systems around this functionality, we need to abide by the specifications that eventually will evolve by 2027 second quarter. So that is about the EMBB enhancement. And similarly, massive machine type communication, current density that we have seen is 10 power 6 devices. That is enhanced by 100 times, and 10 power 8 per square kilometer is what is expected as part of the MMTC enhancement. Similarly, ultra reliable low latency becoming hyper reliable low latency communication. Again, they have defined sub-millisecond latency characteristics that these are the vision with around the user scenarios. So for these existing quadrants being extended to meet these things, and the new areas have been added. One is ubiquitous connectivity. Um, Here again, human to human to machine communication is one of the primary areas here. Brain to computer communication is one vision that we have, and AI and communication, artificial intelligence, um, driving one all these communication aspects. That is one more thing. I have more details to talk about these things, but let us keep it short for now. And integrated sensing and communication. When you have multiple sensors around us, there should be a framework to address the requirements for this sensors part, and also this satellite-based communications also come under this category. And these extended capabilities are expected capabilities of 6G. Let me show closer look at this. Um, okay, let us understand this lower part first and then go to the other one. This inner circle is IMT 2020, the 5G part, where we have defined reliability, latency, mobility, and connection density. These things are being extended to sixth generation. By reliability is enhanced by 100 times, and latency coming to sub-millisecond, zero point 0.1 to 1 milliseconds is the latency. Earlier, as part of 5G, we have envisioned up to 1 millisecond is a good number. Similarly, mobility at 500, sorry, mobility at 500 to 1000 kilometers per hour, and connection density, again, as I told you already, 10 power 6 to 10 power 8 devices per square kilometer, and area, traffic capacity, etc. These things have been enhanced. Similarly, the new capabilities that are being added, I hope you are able to see my screen, this enlarged diagram. So positioning is one more thing. Within 1 to 10 centimeters is the positioning accuracy that's expected because of various industry automation, cyber physical system based communication systems. That we need to have much more accuracy with reference to the positioning, or positioning is going to play a major role in carving out the systems using sixth generation technology, and interoperability, sustainability, etc. These are the primary capabilities that 6G system is envisioning. And this diagram is known as pellet diagram, and this diagram is known as wheel diagram. Well, so this is about the 3GPP standards, the way they are evolving from release 15 to release 20, five releases across two generations with one intermediate 5G advanced. This is the journey that we have been undergoing. And when you think about the mobile communication fundamentals, these slides may be not for those who are already exposed to the 5G systems and mm, are already working, but for definitely new people, those who are in the undergrad. I see some participants are in, students are there, and some of them are from startups, etc. For them, this I believe, I hope this will be useful. So this is the general structure of the communication system. So one radio access network, one core network. These are the minimum essential systems to have a communication system while when a UE wants to enjoy some service. So what is this radio access? When I think about say two machines getting connected, I'll have maybe I'll have a direct cable, and when I send one message from one machine to the other, I need to have some kind of transport definition, like how this message has to reach there. If it is a visible communication, actually I can wave at a person or I can shout at a person, and that person can see me. And with the gesture I am making, which is nothing but the coding scheme that I'm incorporating. That fellow also knows what my gesture means. If he knows, he can understand and respond to the gesture I make. Um, Whereas when you think about the systems, that kind of mechanism we have to mimic into the systems, and that is what we are doing across any network between either it's between two computers or between a handset and a network or in any such systems from a controller to a controlled device. Say for example, when you unlock your car, what you're doing is you're taking your remote car key and pressing some button. That button has some functionality that communicates certain signal to the entity, and that certain action is being taken on the other side, provided this signal reaches the car, and the entity sitting inside the car, which is responsible for receiving this communication, is able to interpret and um, initiate certain actions further down on certain lever operation or something. So the similar system we have to have in the radio network. Mobile communication is not an exception to that. So I have a central tower or a radio tower associated with some circuitry, associated with some um, entity, what we call generally as a G node B. That G node B, and I have a radio modem on the handset which can talk to the radio system on the tower and make a meaningful dialogue with the radio. And um, obviously, this UE will be requesting for some service, and if the RAN itself can cater to that, it will be able to do. But that is not the purpose of RAN. RAN means radio access network. So in turn, it will talk to one service provisioning entity, which is part of what we call as a core network. And that core network will have certain activities to do, and that will uh, um, try to cater to that service. Typically, handset can request for a data-based connectivity request or a voice call-based connectivity request. If it is a voice call-based connectivity, it will go to the PSTN system or IMS system, IP multimedia subsystem. Or if it is a data-centric activity, it will go to the external data network. One typical example is, say, if you want to browse internet or if you want to watch a Netflix video on your handset, what you do is you will open the Netflix app in the handset and start searching and click some video. That request will reach the RAN, and in turn it will go to the core network. At the core network, some evaluation will be done about this particular handset and eligibility to access particular data service. And if it is possible and if it is allowed, that core network will enable and extend the connection to the external data network. In this case, external data network is a Netflix server. So Netflix server will respond according to your subscription details and start streaming the video to this particular entity through this backward communication. It will come back to the core network. From the core network, it will reach the RAN somehow, and from RAN, it will reach to the handset over the air interface. And this is the way the communication system operates. Well, we have a management system here, which we will talk about a little later, not immediately. And when I think about this 5G system, there are three terminology broadly we use. One is the RAN, second is the core network, and UE, user equipment. DN, of course, the data network. The data network is not part of the 5G system. 5GS stands for 5GS, 5G system. By the way, this picture I have taken from TS 3GPP technical specification 23.501. Again, there are multiple things like 38 series, 38 dot something will refer to the 5G specifications. 36 refers to the LTE system. 23 refers to the architecture documents, etc. There are different series of 3GPPs, 3GPP specifications. And when it comes to the 5G system, this shaded portion is what we know as core network, or this part. This part. And RAN, of course, is radio access network, which can talk to the user equipment. Inside the core network, I'll have certain functionality which can actually authenticate the user. When a user, if you take a Airtel SIM card and try to connect to the Geo network, It is not possible unless there is a roaming agreement and UE is under the roaming scenario, etc., etc. That activity happens at authentication server function. So there is a base connection happens to the access mobility management function where RAN directly talks to the AMF. I have more details here. Don't worry about the structure of this, but main components within the core network are AMF, access mobility management function, which admits the UE, enables or is mainly responsible for handling the authentication and invoking the rest of the services for the particular UE and mm, maintain the health of the connection, etc. I'm still again talking at still talking at 10 kilometers above there, but that is the AMF functionality. Next core important thing is session management function, which enables a data connectivity or voice connectivity, whatever it is, a service request being catered using one session. One session is per any request. If I have, say, for example, I have a, while I'm talking, someone asked me to share some information. So I immediately open a browser and extract that data piece and again, speak back to that person and say, this is what it is. In that case, I'm initiating two sessions, one for voice call, one for data call. So those things are handled by these two personalities. They are responsible for setting up such a dual connectivity to the system, two sessions, not dual connectivity, but two sessions for the system. For that, we will have additional functions like mm, authentication has to be done and uh, charging function has to allow this particular connection to happen because if you are on a prepaid mobile service, a prepaid card, if I am on the brink of consuming my balance, reaching the zero, I may or may not be allowed. Or if I am allowed also, after I consume that amount of money left in the system, I should be, I mean, my connection would be terminated there. So those things will be done in association with PCF, session management, policy charging function, session management function, and UPF. Like this, individual functionalities cater to very specific actions with reference to the request that a UE is originating and trying to enjoy certain service. That is the functionality of the core network. Radio access network, of course, takes the data from the network, puts over the air interface, and um, start transmitting to the specific UE. So those specificities of the UE identification, etc., are done through something known as um, radio transport network identifier, etc. Those things are there. RAN, RNTIs, what we call it as. So this is the stack. Hmm, Time is running very fast, really. This is the usual stack that we see on the. There are two concepts again. One is um, CUPS, control and user plane separation. What we do is there is a transmission grid, what we call as time frequency grid. On that, we will identify for individual time slots over certain frequencies. I don't have a picture for that, but visually you can imagine what it looks like. On the y-axis, if I take frequencies, on the x-axis, if I take time slots, that gives me a matrix. In that matrix, I can each point, I mean, slot is set for certain duration, frequency is for certain range, for certain band, right? So that way, if I consider um, for one frequency for one particular time slot, I can see a small square corresponding to that. Within that square, I can transmit certain data. Certain data. So I have a set of squares depending on the number of time slots versus number of frequencies or the what we call as subcarriers. That time frequency grid can be utilized for sending certain control information, certain data, or certain synchronization signals, or certain. It is a bidirectional grid, by the way. And in 5G or in the mobile communications, handset or the UE is a absolutely dummy device. Absolutely dummy device. And GNODP tells the UE to when to transmit or when to receive the data and what type of data it is being transmitted or what type of data it is expecting from the UE. That is the way the communication happens. For that, the stack, whatever the entities that are responsible for handling this data transfer or certain type of data transfer, are segregated into control plane and user plane. Control plane talks about establishing connectivity and exchanging the information of the handset with the access mobility management system, etc. It is responsible for establishing and maintaining this particular data connectivity. That is the user plane part. Whereas this entire thing plus some part of the G node B will be acting in the control plane, which is nothing but this. Between UE to G node B, um, in the morning, Professor Anurag was talking about the quality of service. So this service data adaptation protocol is responsible for such quality assurance over the air interface. Between UE and G node B, I have air interface, right? So for that air interface, what should be the quality? How this particular link can actually meet the that particular quality of service, that is defined by this. PDCP is a packet data convergence protocol. Um, this is more for mm, arranging the packets and what it does. It actually sequences the packets so that we know what we are sending down the line and what is still pending, etc. And RLC does some level of error corrections, etc. And that's called radio link control. It does some level of error correction, and it segments the incoming packets into a handleable size and transfers that to the MAC. MAC is Medium Access Control Protocol. This schedules. Um, Professor Anurag in the morning was talking about scheduler actually takes care of, even if you have a strong file layer, scheduler is the actual entity that um, assures that we meet the quality of experience or quality of service. So that is what it is. So these things together send the data to the file layer, and file layer will actually handle actual communication. So that is why I would say the access stratum contributing stack is rest of the protocol stack other than the file layer. 5 to 5 is the access stratum. Access stratum refers to the air interface. Only over the air connection is known as access stratum, and rest of the things are uh, these things are non-access stratum, etc. That is how the terminology is. And let me move on. When we look inside a bit into the core network, this picture is familiar to us, right? We have different network functions, what we call here as a network function, not the network element. Until previous generations, they were called as network elements. Like if I take the GSM days, I have a BSC, base station controller, and I have a BTS, and I have a ONCR. These are the network elements. They are standalone software running on a dedicated hardware. And there is different types of connectivity defined through something known as ACC cards, acceleration communication cards, etc. They define the interface between the entities, like I was telling, between two computers when I put a connectivity. Those things are taken care like that. Whereas here it is more of softwareization that is being brought in. That is what we were referring to as virtualization in the previous slides. So with virtualization, I can have this set of core network functionalities either on the cloud or on any dedicated system in a integrated or disaggregated fashion. So please watch out these words. One is I can put everything on the cloud, where I have a remote on the cloud. I can put network functions and establish connectivity with some IP addresses and get the functionality happening. And that is one way. Other way is I can have a standalone AMF server, standalone SMF server, standalone UPF server. Like this, I can have uh, individual machines or individual servers running in this. That's another extreme style of deployment. Depending on the volume, depending on the customer base, depending on the traffic conditions, we can take different types of deployments. There is no hard and fast rule for these things. At the same time, UPF or the user plane function has certain deployment styles. Again, it can be integral part of the core network, or it can be deployed along with the RAN. Where if I have any latency sensitive applications running in the service area, I should have the UPF co-locate to the co-located with RAN, so that this link itself will not introduce any additional latencies. Usually, when we talk about the latency, we talk about um, this is the 5G scope, or this is the scope of control as far as the latencies definitions are concerned, UE to UPF. Beyond that, I don't have control, right? When UPF tries to access the network Netflix server, as I was citing in the previous example, this Netflix server may be somewhere on the other side of the world. We don't know. So I don't have any control on the latency of a connectivity over N6 part. All that I can define is between UE to UPF. And when you see the internal functional model, there is a request reply or subscribe notify. Maybe in the interest of time, I don't get into the details of the system here, but let me tell you one quick way. When certain network function comes up in the system, it will notify the network repository function that I am here. With that alarm, or with that indication message, this repository function maintains the database of all the functionalities that are available within the core network. And instance of a particular SMF, for example, SMF says I'm here. This knows that okay, SMF is available and up and running. So whenever any AMF requests for an SMF service, NRF will tell the AMF that okay, so and so SMF you can talk to. That is the way this model works. Or there can be a hard-coded style also. In the AMF, I can tell list of SMFs and SMF IP addresses, so that AMF straight away talks to a specific SMF. That is also possible. There are very different types of deployment models. Okay, so we know a little bit about the RAN. We know the little bit about core network. Between RAN to core, that is very important interface that we have, because that interface carries both control plane and user plane. Control plane and user plane. Because of this RAN, one side it is talking to the user plane function on N3 interface, other side it is talking to the AMF, which is the core part of the core network. So NGC talks to the AMF from the access node, or 5G AN, or 5G RAN, or G node B. All these names are synonymous. 5G access node is talking to the AMF over NG interface, or the NG AP is the next generation application protocol. This governs the connectivity between the G node B and access mobility function. Whenever a G node B comes up, in the G node B configuration, we tell to which AMF it has to connect to through the IP address of the AMF. So this connection goes live once both these systems are up and running. Then this RAN will be able to, anyway, it is seeing the handsets over the air interface. Whenever there is a UE request for authentication or any service request or those things, it will talk to, okay, by the way, UE doesn't know anything other than the RAN. So it will this first contact point for the handset or the user equipment is the RAN. So it'll that request comes to the RAN. RAN will talk to the core network over NGAP, carries this UE information to the core network. Inside the core network, it will do certain activities, etc. That functionality will happen. Connectivity between these things is, this is the air interface, and this is SCTP based connection. SCTP IP is the protocol stack. Here we have a concept called radio network layer and transport network layer, or RNL and TNL. The reason I'm telling is, when I was citing the example of connecting two computers with a cable, that cable can be anything. It is not necessarily that I have a RJ45 cable. I can have a fiber cable. I can have a Bluetooth connection, or I can have any other type of modem, or I can have a 5G modem which can connect, or I can have a something known as a time sensitive network, etc. There are multiple things possible. So that is about the thing. And user plane is RAN talking to UPF. This is the entry interface, which we have seen. And in the interest of time, let me skip this. And transport network can be SDN. SDN is um, SDN is a what does that stand for? I have forgotten the expansion for this. Please forgive me for this. But SDN will actually software defined network. This can actually shrink and expand the network according to the needs, and it can actually give a packet prioritization depending on the type of packet, etc. See, in the UPF, we are saying quality of service can be met depending on the type of request it is making, or based on the user profile. That is not just sufficient, right? Because I'm connecting this RAN and the core network where UPF is running through a transport layer. The transport layer, if it is not strong enough and if it cannot really support the required data rates, or support certain quality of service, or support certain type of packet prioritization, it is of no use. Still, we cannot meet the requirement or the quality of experience. So for that, transport network also has to be intelligent enough, capable enough. That is what SDN can offer. So this is one option of transport underlying transport network. Well, okay, in the interest of time, I skipped this slide, the explanation, but what we have done here is we ran the core network in University of Surrey in UK, and we have run the RAN in the IASC 5G testbed here in Bangalore, and we have connected one handset from here to one handset inside the RAN operating in University of Surrey, and we have done a video call between Teams call basically between these two handsets. When George Freeman, Minister of State from UK, was with us, we have made him talk over our 5G network with one of our counterparts in UK. But by and large, when I do a speed test, etc., in this configuration, this is what we have witnessed: 94.2 downlink and 6.95 as uplink throughputs that we have observed. And
Sorry, if I
okay,
can interrupt here, please, Mr.
yes,
Sudhakar.
please.
For that Surrey University use case which you mentioned, was that limited only for a video call, or was there any machine-to-machine communication also feasible through this solution?
It is feasible, but we have done only a video call. We did not went ahead with further things, but that we can still do the latency experiments, etc. That was the
Sure,
intention of setting up this test bed.
sure. Thank you so much.
So now we have seen that RAN is a one single piece, but it is not. I mean, the story doesn't end there because of this release evolutions, etc. There is a proposal, or there has been research done around splitting this stack. When we think about the RAN stack, we have seen these things, right? We are saying that on the control plane, I have non-access items. Okay, that's not the protocol thing, but RRC, PDCP, RLC, MAC, and PI. Similarly, SDAP, PDCP, RLC, MAC, and PI. These are the user plane and control plane stacks. These stacks we can actually divide into pieces, run on individual systems, where we call them as, say, for example, if I consider this option 6, for which the split interface is defined by small cell forum specification number 225.1.0, that talks about I can run this portion of the stack on one system and this portion of the stack on the other. What we call this part as a VNF, virtual network function, and this part as a physical network function. Advantage is one VNF should be able to talk to multiple PNFs, so that mm, instead of spending on a complete stack on each G node B, I can actually bifurcate and use the control part of the stack as a repeating thing, where um, data centric activities are less as far as the capacity demands are concerned. What I mean to say is, when you receive the data here, this is our entry point, right? This is the uplink portion, and this is the downlink. We are transmitting the signal from the G node B to the UE. This is the exit point here. So this is my downlink. I'm receiving data from core network, and I'm doing all this packet assembly, all these things, and scheduling and doing some level of error handling, etc., or packet loss handling mechanisms here in the Mac. And I'm doing the modulation, doing pre-coding, etc., and doing the inverse past Fourier transform and putting on the analog D to A conversion. And here I do the RF activity, like I do the upconvert that to the allocated center frequency of the G node B. Say like if it is band 78, it is 3.3 to 3.8 gigahertz. I'll be allocated with one center frequency, say for example 3.5 gigahertz. So I move my data to that frequency zone and transmit the signal. That is what is happening in this chain. This stack can be split at option 6 if I consider this part. So my scheduler will be running in the VNF with multiple PNFs. So in that case, I'll be identifying to individual PNF to which the scheduler has to schedule the data for transmission. Like this, I can split things. Another uh, set of split options that have been surfaced are 7.x. What you see here is 7.1, 7.2a, 7.2, 7.3. 7.3 is mostly driven by Ericsson with certain flavors. Maybe these links can give you more details. Uh, by and large, 7.x split. That is what we call it as. This split actually suggests that we have a EC3 based interface. Sheila, do I have permission to extend the session by another 10 to 15 minutes? Would that be okay? I think post my session, it is the lunch time only, right? Oh, sorry, Saurabh Mittal is there. Okay, I'll try to be on time, but maybe I may have to extend 5 minutes. So this is the 7.3, 7.x split, where it suggests to have a EC3 based interface between the systems that we are splitting. What we call is this side it will be called as a DU, distribution unit. This side it will be RU. That's the way it is. And this, if we take another split here somewhere, that will be CU, DU, and RU. That is how the thing is. This is how the typical deployment model looks like. And I have a CU stack and DU stack running and RUs. So here, CU will be doing these two things. PDCP and RLC. RLC activities will be, sorry, RRC and PDCP happening on the CU. And RLC2 up to, say, for example, here, let's take 7.2 split up to here. This part will be my DU and pre-coding plus up conversion, etc. Those things are RU functionality. If I consider like that, this is my DU stack will be running here. One DU can talk to multiple, I think there is a typo here, multiple CUs, and multiple CUs can talk to, sorry, multiple DUs can talk to RUs. Yeah, this is CU, DUs, RUs. And with the type of interface that we define between these entities, we can actually operate up to maximum of 40 kilometers span with a fiber optic link running between CU to DU. And similarly, DU to RU, it is about 20 kilometers. It's a typical deployment model that has been uh, recommended. This is a typical, okay, why do we need to have this kind of split architecture? Obviously, yeah, we are happy with monolithic stack and it's happening well. Why do we need this? It is like with this disaggregated system, I can have DUs, uh, one company manufacturing only DUs, one company manufacturing only CUs, one company manufacturing only RUs like this. And I should be able to do a mix and match because of a common specification that's being followed for the interfaces. In theory, it is very green, but in practical, it is quite difficult to integrate these systems. One, okay, maybe I'll skip this TSN part in the interest of time. This also I'll skip. Um, Okay, I'll come back to these slides. Let me show you one quick example. This is the radio unit from VVDN, and we have practically implemented CUDU on a server grade PC with time reference being given from a GPS unit. With this, we were able to achieve 340 Mbps with a 100 megahertz bandwidth compared to a 40 megahertz bandwidth monolithic system at stands at 86 Mbps downlink, etc. This having 106 PRBs, this having 273 PRBs. But this system is feasible. Here we were using open-air interface or the OAI stack for CUDU, and this is a commercial audio. This integration has taken us quite some time. It is not that easy as we are talking about here that DU can be purchased from somebody and RU can be purchased from somebody and integrated. That won't be that green, but it is doable. That's what I wanted to say here. And when you have this large scale system, we obviously have to have a management plane. That is the principle of ORAN system. Here I have a CU, DU, and RU. This is my complete Gnode B functionality to which we are adding some management entities which can monitor and control. Okay, NMS talks about FCAPS functionality, fault management, configuration, accounting, performance, and security. Predominantly, people will do fault and configuration management and performance management. These three are very widely done. For that, we have frameworks defined here through some Yang models, etc. In the interest of time, let me run through faster. So there are variants for deployment, etc. So, and we have also done some kind of power consumption study with this BVD and RU, where under loaded condition, we have seen CUDU combination is consuming about 15 watts additional power. On the RU side, it is only 1 watt increment we have seen when we were doing a video call between two handsets. And also latency measurements from UE to UE stands something like this. And UE to core, what we observed is between 17 to 22 milliseconds for the lab configuration that we have deployed. And cyber physical systems, let me quickly walk through these things. Okay, I skipped this also. I had a lot of material, but we lost a lot of time also in the beginning. Use cases versus applications. This is what the 3GPP technical standard, the technical specification 22104 talks about. This is a very good document. I strongly recommend all of you to go through to understand what is that we are looking at factory automation to in the future. This is actually an intermediate step between 5G to 6G. This is an intermediate step. That's the reason why I'm emphasizing this very specifically. Here, factory automation, process automation, human-machine interaction, logistics and warehousing, monitoring and maintenance. These are the primary use cases that 3GPP is envisioning, for which it is not limited to these set of applications, but we can do many more, like mobile robots, like those warehouse monitoring things will be there, right? Like forklifts, etc. They can be automated. Forklifts are the easy prey that experiments will be done on. So these kind of things, we can think about various applications for which positioning will become a critical requirement, as well as latency to some extent. Still, it is not very mandatory thing. Like this, there are various use cases that are possible. Let me, unfortunately, I'm not able to discuss too much of detail about these things. And this is the communication system that we want to establish at Art Garage at IAC. This is integral part of IAC, organized through the entity called Art Park, which is again part of the IAC. Artificial Robotics Technology Garage, where we are doing the experiments around using these things. With a commercial monolithic Gnode B, what we have done is this. Let me show a quick video here. I don't know if audio I have shared with this. Here you can see the Gnode B we have connected outside the window, and we are arming a drone. That was the thing. And this is the unit that takes the roll and pitch information of the drone. This will be mounted on the drone with the 5G module. This is the 5G module currently connected to the monolithic G node B. When he moves this plate differently, you can see that data here. This is the roll and pitch view. This is a UTM software that we are currently experimenting with, where when we start a drone, this is the geofencing system under which the drone is identified. When you see here, when the drone moves, this pitch and roll information is, or the telemetry information from the drone is being transferred to the UTM software running on a system through the G node over the 5G link. This is the experiment that we have done. And also with this system, we were able to do a drone. We have flown a drone. This is the very first experiment. So I have not edited anything in this. You can hear those surprise factors, etc. But I'm proud to share this video with all of you. So yeah, this is in summary. Here we can control this unit using, yeah, if you see here, this is the 5G module with antennas, and rest of the system is integrated in the drone. Okay. And the landing is done through remote control, but it is possible to do either way. This is the RC with which he is not doing anything, but it is completely controlled from the UTM software. Okay, let me move ahead. This is the indoor positioning system that we are building. This will be will be a reality in the near future. Specifications for this are covered as part of 38305, and additional specifications are there. Maybe in some other discussion we can, I will be able to explain and maybe even demonstrate this system. Yeah, 5G positioning is done it can be done either at G node B, or it can be done at UE, or it can be done at a location management function, while UE transmits its measurements through a serving G node B. That is the main theme of this thing. There are multiple things here. Yeah, sorry, I'm really very sorry for not able to cover the details here, but that is the way it is. Yeah, 6G I'm skipping, and we are doing two courses here. One is as part of IACEC department, we are teaching 5G through the talent sprint. I have been covering these aspects as part of this 5G course. Here I have provided the link to the talent sprint webpage, where you can see the faculty and what is being covered, etc., etc. Those details. This we have already completed cohort 3, third batch. We have started this course in 2022. We have completed 3 batches so far, and this is the upcoming course Sheila was mentioning about. We are planning to float a course with from ArtPark, where it will be an intensive practical oriented system is what we are envisioning, with the test facility that we are building at ArtPark. So you can do the practical experiments apart from covering the theory. Basic module will cover complete basic overview, and most to the best possible extent we want to put it practical oriented system. And in the advanced module we are planning for mini projects, etc. So once a person completes this system, they'll be having a complete understanding and hands-on experience with still, of course, some part of commercial deployment, some part of the lab grade systems, with some level of simulation as well. But they will be able to understand the monolithic versus ORAN systems, I mean, split architectures and ORAN platform. That's the idea we are looking at. And yeah, let me conclude here. You can reach out to me on my mail ID, or this is my LinkedIn LinkedIn profile. And thank you very much for giving me the opportunity and time.